Okay, so we're going to now use our pad stack editor to create a mounting hole, via, and fiducial. And we'll talk about through some of these standard ones here. Now, we're not going to have to make many pad stacks for these because once we kind of have one or two mounting holes, we'll use the standard ones. Or once we have one fiducial, we're going to use that fiducial all the time. Same thing with kind of for vias as well. So the via we're going to go through here as a side note, in this example is not going to be the via that we're probably going to use for layouts that you make, because again, um, we are using a different system to actually um, plate, because we don't have a plating system. We either have to solder a wire or do a grommet method in order to um, get the top and bottom side of the boards connected. So, but let's go ahead and first start with our mounting hole. And let's first start with an unplated mounting hole. So I've selected mounting hole, default pad geometry of circle, change this to millimeter, and then let's do an M2 unplated. So M2, if I look at the table that we wrote down, that has a 2.4 millimeter drill hole. And then notice here it says hole plating. I do want to actually list this as not plated. Um, all of the other poles that we've already done, any kind of pad stacks for footprints would be plated holes. Even if we're not doing the plating ourselves right now, in general, you would want those holes plated. But right now we have non-plated holes for this particular um, mounting hole that we're doing. And so with that, we have that. Now we also have to do a drill symbol always. I'm going to go ahead and show you what the drill symbol actually does in this particular one here. So I'm going to do a drill hole symbol. And what I'm going to do first here is I'm going to purposely um, not do the size. I'm just going to do 1 millimeter. And you can see this black circle appears here. That's actually the symbol. If I do 3 millimeters, which is bigger than what I need, it's bigger than that. But we, as I said, often do 2.4 to represent it. Sometimes why you might want it slightly bigger is that if you have vias that are sometimes hard to see, you can use that drill symbol to kind of make it easier to see the vias throughout the board. But typically, it's always the same size as the drill hole. This is also something that's really a function of cadence. Other software programs don't really have that. And then even though we aren't doing any kind of um, plating or any kind of copper pad on it, um, we do have to define an internal layer for a pad. And so we have to either do a regular pad, thermal pad, or anti-pad. And so I just do a regular pad. And, you know, again, since we're really just wanting this to be a hole that's drilled with nothing else, I just do a circle. And then I just make it 0.1 millimeters above what I'm drilling so I don't get any kind of warnings or errors. Um, and so you can see I've got a slight blue. And that's to quote trick the program so we don't get any warnings or errors. Because again, this is literally just for us to drill a hole straight through for mounting type. Um, as a side note, they recommend for various reasons that, you know, it's often better to do copper based plated mounting holes. Again, oftentimes we use that as a way to ground the mounting holes, and sometimes then if it's an aluminum casing or something, the aluminum casing then becomes a ground as well. So there's various reasons why we choose to do things with those mounting holes or we choose not to do those. But um, to do just a hole with no copper plate on the top or bottom, this is the way we would do it. And then I would simply save this. Now, I was actually in the directory of where actually Cadence stores all of their pad stacks. So these are all default pad stacks created by Cadence. And you can see they don't follow the IPC naming standard at all. And you can see why it's kind of bad to not follow these in the sense that it's like pad 1, 2, 3, 4, 5. Okay, well, what does that doesn't give me any information about the actual size of the pad or anything, so that's one of the reasons why we wanting to follow the IPC conventions. Or if your company doesn't follow IPC, that would be where you'd want to follow whatever conventions your company uses. And so let me go back to DWR, OneDrive, Cadence, and where's my pad stack here? Pad stacks. Okay, so there I have my bunch of pad stacks here. Now I've actually already created this once, but I'm going to go ahead and type it in here using the naming conventions. I'll bring those over onto the screen here just so we can see them a little bit. We have the W that we use for a mounting hole, and then we're doing non-plated hole. So we have W, and then we have a hole because there's no copper plating going around as far as the land or anything. So we just will have W, and then we will have HN for non-plated hole. H is for the hole, N is for non-plated, and then the size of the hole, which is 2.4 millimeters, so it'd be 240. So we'd have W, HN, 240. And it's going to say, do you want to overwrite this? Because as I said, I already created it once. And I'm going to say yes, I'm going to overwrite it. Okay, great. So that is one of our mounting holes. Now let's go ahead and do a plated mounting hole. Basically the same idea here. One thing we have to be a little bit more careful about is the actual copper pad that goes on there. I mean, it's nice to sometimes just, quote, follow that, rule as far as like, oh, well, let's just, have a formula for it. But for this, it's going to be a little bit different depending on what is being used to mount there. So what do I mean by that? Well, instead of giving this a name right now, I'm just going to call this test, just because in order for me to know the name, I need to know all the dimensions at this point, and I don't know the dimensions at this point. So I'm just going to say test, and then I'll save it using the proper names here later on. Okay, now notice it still says this in millimeters because I haven't changed anything. Let's do an M4 hole here. So an M4 plated, so I'm going to go to drill. And because I haven't quit out of this program, it's still remembering that I had said non-plated, but remember we're going to do plated now, so I need to switch that back to plated. And then the M4 has a 3.4 millimeter hole. So we also still have to do a drill symbol, 3.4 millimeter. Okay, now the design layers. It's tempting to just use the same thing we did for the pad stacks that we did for like components. That's not a good way to do this here. And let me just give you an image to explain why that's not a good way to do this. So I just am going to bring this over here. I just Googled this. Let me zoom in here a bit. So if we have an M4-0.7, the head diameter of that bolt is 7.6 millimeters, and then the head height is 2.2 millimeters. Not concerned about the height at this point, but the head diameter, 7.6 millimeters. So if I'm thinking about this here, let me see if I can Google this here, PCB mounting hole image. Here's the picture that we're doing. And here's another one for a grounded one. And it's showing the different types of mounting holes here. But what I'm trying to show here is this is definitely bigger this copper area than our standard, using it for our pad stack. Um, and because that's much bigger, we have to think about the fact that, oh, well, why would that be much bigger? And that's either because maybe there's a washer, or again, the head of the bolt is big enough, and we want to make sure that that head of the bolt, basically, there's enough for copper pad exposed, um, so that bolt, when we tighten it down, is completely like that copper is covering the entire portion of the head. There's again, um, some of the reasons is for connectiveness, as far as if you're using it as a grounding hole. Another one is for thermal reasons, because as these boards heat up and everything, the fiberglass can actually wear away and the bolt could loosen. And so that's why they recommend that, these copper kind of helps stabilize the screws so they don't loosen as the board is used and the boards heat up and cool down. As a side note, this picture is a little pretty cool one here. I've actually never encountered this. That obviously doesn't mean they don't exist, because clearly they do, but a threaded mounting hole, which is kind of cool. All right, so with that here, and I just closed out the window I wanted to keep open here. Let me just do this M4 bolt hole head diameter. Okay, so it's 7.6 head diameter. So if we're thinking about that, we could kind of use our formula then for what we did for the pad stacks if we wanted to, or we can, follow if you have a company standard or something like that as far as how big to make it. I'm just going to go ahead and follow the standard that we had for the pad stacks, and instead of using the whole diameter, I am using the head diameter, which is 7.6. So as far as my computation would be here, let me pull up a calculator. I would have, using a level A, 7.6 plus 0.1 plus 0.6, 8.3. So I would have this being a circle of diameter 8.3. And you can see this even kind of looks similar to the mounting hole that we saw. Eight point three. All right. Now we should add mask layer to this as well, because there is going to be a solder mask applied. And so the solder mask is actually 0.7 all around. So it's really the radius is increased by 0.07 millimeters is what the radius is increased by. So the diameter is really increased by 0.14. So let's go here, circle, design layers 8.3, and so this would be then 8.44. And then we do the same thing for the solder mask on the bottom. Okay, now I'm not going to save this as a test because that's not a good thing here. So let's save this. Okay, so now how do we save this? Well, we can just do W. Now we don't have to do a C for circle, because it's kind of assumed just with basic shapes of mounting holes that it's a circle pad by default. Unless it was a square pad or something like that, it's going to be assumed that, oh, for a mounting hole, you're still going to have a circle by default. Now you could still put a C in there if you wanted to. It's not incorrect, but I'm going to ignore that for now. So the pad size is 8.3 in diameter, so 830. And then my hole size is 3.4, so 340. And so there's nothing else we need to do at this point for this particular one because the hole is plated. There's nothing special else that we need to talk about with this naming convention. So most of our pads are going to be fairly simple because we're not going to be getting into the complex naming conventions. So I'll save that. And we'll go ahead and end this video. I'll do a via and a fiducial in the next one.